Hi everyone, we are going on into 11.5 now, which is alternating series. So we're almost halfway through chapter 11 at this point. And so at the end of this section, we'll kind of stop and kind of rehash a little bit about what's been going on in the past few sections. But this is just a different test if we have an alternating series where our series has a term that's added, then subtracted, then added, then subtracted, back and forth like that. So an alternating series is a series whose terms are alternately positive and negative, kind of like what I just said. And so the alternating harmonic series is one example of that, where you start with a positive one, and then a negative one half, a positive one third, a negative one fourth, and you just keep adding and subtracting numbers in that same sort of pattern. And we talked about a little bit earlier in one of the other sections that your alternating harmonic series is actually convergent. And I can show that by this little blue box down at the bottom where it says if you have an alternating series where you'll be able to usually pick off alternating series pretty easily because somewhere in the problem they'll have a negative 1 to a power times the rest of the part. So the rest of the part, the b sub n here, that's your regular sequence, and we're just alternating it with the negative 1 in front. So we have to start off with a positive b1, then a minus b2, and so on. So one condition that tells you that this is convergent is that all of these things, all these b sub n's, have to be bigger than 0. So you have to have positive values other than the fact that it's alternating the signs. So we have to have our b sub n's have to be positives. The first stipulation down below that says satisfies b sub n plus 1 is less than or equal to b sub n. That means we have to have decreasing. Ooh, that does not even look like decreasing, does it? Let's try that again, just for good measure. Decreasing. That looks a little better, maybe. You have to have decreasing terms. So like in our alternating harmonic up above, each term down the line is smaller than the previous term. Now, they could also be equal to the previous term, but they have to be at least equal or smaller. They cannot be going bigger. And our limit has to go to 0 if you take the limit of the sequence part, not the negative 1 to the power part, but the rest of it. So if all three of those is true, then the series converges. So let's try one like this. Test the series for convergence or divergence. So you may want to rewrite this in sort of your summation notation. If you want to do that, that's perfectly okay. This one's not too hard to come up with what the actual series would be. Notice that there is a 2 on the top of all the fractions all the way across, so apparently we should have a 2 on top. So I'll put a 2 on the top. And so I got to figure out a relationship of if n equals 1, 2, 3, 4, 5. How are you getting those bottom numbers? And so this one's not too bad to notice. Hopefully you notice that if you take your n value and you double it and add 1 to it, you would get the number on the bottom of the fraction. 1 doubled is 2 plus 1 is 3, or 2 doubled is 4 plus 1 is 5. 3 doubled is 6 plus 1 is 7. So we probably have a 2n plus 1 on the bottom, starting when n equals 1, going to infinity. Now the signs alternate. And so since it's a positive term and then a negative term, then a positive term, then a negative term, you'll need an alternating term along with your b sub n. So we'll need a negative 1 to a power. So in this case, you could do either n plus 1 or n minus 1. You got to make it so that when you plug in 1, you'll end up with a positive 1, not a negative 1. And so plus 1 would work. 1 plus 1 would be 2. So the negative 1 squared would be positive 1. So that would work, which would be good. So That would be my sequence, the 2 over 2 n plus 1. That's your b sub n sequence. The whole thing is your series. And so I want to check these 3 different little categories. So I'm going to check each one. The first one said that all your terms had to be bigger than 0. So your b sub n being 2 over 2n plus 1 had to be greater than 0. And it would be. You can't possibly be 0 because the top of the fraction is not 0. It's 2. And the bottom, if you're starting with 1, your smallest number you'll ever be will be 3. And so, yes, this is always going to be a value that is greater than 0. Your second stipulation, you have to have b sub n decreasing. You have to have b sub n plus 1 had to be less than or equal to b sub n, which means you're decreasing. And you are. If you look at the series up at the top, you have a 2/3 that goes to a 2/5, 2/7, 2/9, 2/11. Each term is getting smaller, and so yes, that checks out as well. And the third stipulation is that your limit, as n goes to infinity, of 2 over 2n plus 1 has to be 0. And it is. If you notice, there's more n's on the bottom than there are on top. There are no n terms on the top. So on the bottom, you just have 2n plus 1. This would eventually go to 0 as n went to infinity. Your denominator would keep getting bigger and bigger and bigger and bigger. So all three of those stipulations hold. So then we could say, therefore, this series converges by the alternating series test, which I usually shorthand to AST. And that's how the alternating series test works. So let's try another one. This one says the series, test the series for convergence or divergence. Again, I'm going to do the same sort of thing. See if I can't come up with how you write this as a series. And we'll just start with 1 to infinity. So the top part, you'll notice, doesn't stay the same like it did on the last one. So we're going to have to use this n equals 1, 2, 3, 4, 5, all the way across for the top and the bottom. The top, pretty easy to notice. All we're doing is doubling the n value. So 1 doubled is 2, 2 doubled is 4, 3 doubled is 6. So the top part must just be a 2n, and that's it. The bottom part might be a little harder to notice, but it's not too bad. You'll notice they increase the same amount, 5, 6, 7, 8, 9. And so since they are a linear in progression upward, then it's probably just a n plus a number. So to go from 1 to 5, we added 4. So it's probably just n plus 4. And you can check it. 4 plus 4 is 8. 5 plus 4 is 9. So yeah, that would work. And we're alternating here. So we have to have a negative 1 to a power. The first term is negative, so we could just put an n up there, and that would work. So that works pretty well. So let's do some testing here. This little part right here would be my b sub n. So first stipulation is that all of your terms have to be bigger than 0. Not the alternating part, just the other part. So if I did the b sub n being 2n over n plus 4. Well, as you plug in 1, 2, 3, 4, on the top you're only going to end up with positive numbers because you're plugging a positive n into a 2, so that's going to be a positive. On the bottom, you'll have a n that's positive. Adding something to it will always be positive. So yes, this will always be greater than 0. So that checks out. Secondly, the second stipulation was that you have to be decreasing. B n plus 1 has got to be less than or equal to B sub n. This one is not going to hold very well, because as you're going down the line, 2/5 is 0.4. 4/6 is 2/3, which is 0.67. So actually, even this first one, or you could write 4/6, but it's going the wrong direction. They're getting bigger as they go along. This does not work. So this one, bad. Bad, 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 bad. If you wanted to check the third one, you can. You don't have to. Since it failed the first one, it doesn't really matter. But as you went to infinity of my... I keep wanting to put a 2 on the bottom for some reason. I don't know why that is. As I go to infinity, here the power for the n on top and bottom are the same. So I'd do the coefficients in front for my limit. That would be 2/1, which is 2. But that's not 0. So again, this part right here is... excuse me. That part right there would be 0. And so here, all my terms are increasing, which is good, but my other two stipulations fail. And so this series actually diverges by the alternating series test. So hopefully that's not too bad. Let's try this one. Show the alternating harmonic series converges. So this is the one I was talking about earlier, and I'll show you actually why this does converge. It does converge. This is actually one of the rare ones we could figure out what it converges to. And so we won't do that here, but I'll just show you that it does converge. So on this one, my b sub n is just 1/n. The -1 to the n minus 1 is not part of it, so you can kind of pull that off to the side. You could write it like this instead, where the -1 to the n minus 1 is out the side times 1/n. And so this 1/n part is your b sub n. So the first thing we need to make sure is that is greater than 0. And it is. If you're plugging in 1, 2, 3, 4, you're going to get nothing but positive values all the way through. So that's good. We have to be decreasing. B n plus 1, sub n plus 1 has to be less than or equal to b sub n. You have to be going down. And you are. You can notice up here at the top, 1 goes to a half, to a third, to a fourth. Each one of them getting a little smaller because we're increasing the denominator. And the third stipulation is that the limit as n goes to infinity of 1/n, that would be 0 because the denominator has more n's on it than the numerator. So the bottom's getting bigger than the numerator. So yeah, that goes to 0. All of our stipulations hold, so this series converges by the alternating series test. So that's why that one does converge, where the one that doesn't alternate it, just the harmonic series that does not alternate, diverges. And we saw that because it's technically a p series. And you can also do an integral test on it if you want to, and show that it diverges. Okay, let's try this one. Test the series for convergence or divergence. Here we have -1 to the n minus 1 over 3 plus 5n. Again, if you'd rather not have the -1 sitting on the top like that, this is actually the same thing. That's -1 to the n minus 1 times 1 over 3 plus 5n. The 1 over 3 plus 5n, that's your b sub n, so that's what we're going to be working with. First of all these b sub n's have to be positive, and they would be. The top is always going to be a 1. The bottom, if you're plugging in a positive n value, 1, 2, 3, 4, 5, whatever, multiplying it by a positive and adding a positive to it will keep it positive, and two positive numbers divided is positive. So that one should not be an issue. Second term, the second stipulation here, you have to be decreasing. Now this one's a little bit harder to notice, but it is decreasing. If nothing else, just plug in, 2, 3, 4 numbers if you want to. If I plugged in the 1, I get 1 over 5 times 1 is 5 plus 3 is 8. Hopefully 1/8 is less than, not less than, greater than. So each term needs to be getting smaller. So if you plug in 2, 5 times 2 is 10, it would be 1/13. So 1/13 is smaller than 1/8. So we are doing good there. If you plugged in 3, you get 15, 16, 17, 18. And the next one would be 1 over 23, and so on. So we are getting smaller. So that stipulation holds. And thirdly, we need the limit as the n goes to infinity to go to 0. And it will. There are more n's on the bottom than there are on top. So this does go to 0. So this series converges by the alternating series test. The alternating series test is also one of the easiest ones to pick off to use, because you'll notice that -1 to a power on there. So anytime you see that -1 to a power on there, you probably want to test whether it converges or diverges by the alternating series test. Okay, how about this one? The series is for -1 to the n minus 1 times 3n minus 1 over 2n plus 1. So again, this part right here is your base of n. That's what we're going to be working with. The other part just tells you that you're alternating. So you need the base of n, which is the 3n minus 1 over 2n plus 1. It needs to always be positive. So in this case, the bottom part, absolutely, you're going to be positive. You're plugging in positive numbers, multiplying it by a positive 2, and adding 1 to it. That will keep it positive. The only thing you really have to worry about here is the top. And so the top part, if you plug in 1, 3 times 1 is 3, minus 1 is, 2. Sorry, brain fart for a moment. If you plug in 2, the 3 times 2 will be 6, minus 1 is 5. So you're going to be growing. In fact, the only way to make it negative on top is that you have to be less than 1/3. And since we're starting at 1, that's not going to be a problem. These are all positive. So we can apply this. So we need each additional term to be smaller than the previous one. So we need to be decreasing. Let's try just plugging some numbers in, like I was doing just a moment ago. If I plug in 1, 3 times 1 is 3, minus 1 is 2. 2 times 1 is 2, plus 1 is 3. So I get 2/3. So hopefully the next one is smaller. I plug in 2, I get 2 times 3, 6, minus 1 is 5. 2 times 2 is 4, plus 1 is 5. Oh, that's not looking good. We went from 2/3 to 1. So that might be an issue. Now officially, you have to be decreasing somewhere down the line. So the first term to second term doesn't really matter a whole lot if it keeps decreasing, say after the third term. It would be okay. But this has cause for alarm right here. So let's pause on that and jump to the third stipulation. The third stipulation, the limit, because the powers are the same on top and bottom, I would do the ratio in front, just like I did on one of the previous ones. This is 3/2, which is not 0. This is absolutely bad. And so, since number 3 fails, it doesn't matter if 2 passed or not. But since that fails, I can say that this series diverges by the alternating series test. And so I'm not even going to worry about trying to figure out does it get smaller, on the 6th term or the 7th term on. I don't care because the third stipulation failed anyway. So hopefully that makes sense. So like I said at the beginning, this is kind of the halfway point of series. So what you'll notice on your homeworks and things, on your quizzes, your tests, whatever, I'll give you a series and just ask you to tell me does it converge or diverge, and you'll have to look at it and say which uh, test would be best used for that situation. And so hopefully you notice that this test right here is what we've been talking about in this section. You have a -1 with an N on it. That is a giveaway, a dead giveaway that we're probably going to be doing an alternating series test. That's what I would pick. The one on the top left, this one, I would probably pick the test for divergence on. Because one thing I notice is the powers on the top and the bottom are the same. So that just looking at that part right there, I would come up with a 1/2 for the limit of that, which is not 0. So it has to diverge by the test for divergence. This one on the top right, that looks like something that I could easily integrate. If you let u be the power, then du, I could use that n in front of it. That would be something I would try doing the integral test on. Really, if you see anything with exponentials in it like that, you'll probably want to do the integral test. And that leaves just one test left over. This one right here, I would probably do a comparison test on. Comparison test because the top and the bottom have things that are added and subtracted to them. And doing that, if I took that part off, I'd have a n to the 3/2 power on top and an n cubed on the bottom that I could turn it into a p-series. Now, you may also wonder, well, could you not do that same sort of thing with this one over here? Could you not do this one with a comparison? And you absolutely could. You could take the -1 and the +1 off and have n over 2n, which would pull 1/2 out in front, will become 1 over n. 1 over n is a divergent harmonic series. So yeah, you could probably try to do a comparison test on there. And that's one thing that I want to stress is that there's not one test that will be the test you have to use. There are many problems out there on series that have multiple tests that you could use. So just because I pick one test doesn't mean that is the only test to do that problem with. So hopefully that makes sense. Alternating series test is usually one of the ones that most people find the easiest. So if you have any questions, just let me know.